Hello, everyone. Can you hear that?
Yeah, speak a little louder.
Hello, everyone. We are going to get started. It's about past now. Thank you for coming, and welcome to all aboard the release train, lessons from our last 100 OpenStack upgrades. So, my name is Alex. I am the release team lead at StackHPC. I am a... Oh, sorry, there we are. I am a somewhat regular contributor to Kolla, Kolla Ansible, and Kolla in the upstream OpenStack projects, and a few others from time to time. I've worked on around 15 OpenStack clouds over the last 3 years, and only one of those caught fire. So not a bad ratio overall. It wasn't my fault. It was a hardware failure. And those clouds have had a wide range of uses, including public clouds, bare metal compute, and of course, AI. And I'm joined today by my colleague, Seunghun.
Hi, everyone. I'm Seunghun. I'm a release train and cloud engineer. I'm a regular Kolla, Kolla Ansible contributor. I've been working on 10 OpenStack systems over the last 2 years. I've done 7 upgrades on them. Thankfully, none of them caught fire.
So for a bit of background on the company, you may have heard of StackHPC already. We won the award. It was formed in 2016, based in Bristol in the UK. We currently have around 40 team members across the UK, Poland, and France, with about 30 of those being engineers. And across that, we manage about 60 systems. We are very heavily involved in upstream contributions. We have always been a major contributor to OpenStack since the company was founded. We've got the second highest number of reviews in the Epoxy release for any organization. And in fact, we've been in the top 10 for the last 7 years. I think we're only beaten by Red Hat at the moment, and they've got like 20,000 people, so yeah. Sorry, one moment. There we are. So our services include bespoke OpenStack cloud design and deployments, plus training and long-term support to go along with that. And we have a specialism in HPC and scientific computing. Right. So, for a bit of background on this, we deploy all of our OpenStack clouds using Kolla. And if you don't know about Kolla, the general idea is that all of your services are containerized. But that's pretty much the only constant throughout all of our clouds. So we offer a range of operating systems. We have no limits on the hardware that we use. So it can be HP kit, it can be Dell, it can be AMD, Intel, whatever. We're even starting to branch out into non-x86 architectures. There was a great talk earlier by Bartosz and Nathan. Thank you. And yeah, they went into more detail on that. And we offer all of the services offered by Kolla, which isn't all of the services, but it's the vast majority of them. And we're a consultancy, so if you pay us enough, we'll add it. So, in the beginning, from around 2016 to about 2020, we took the standard naive approach. So, container images are built on-site for every deployment. Host OS packages are updated whenever we feel like it, but really we're trying to stick to minor OS releases at this point, and we have no centralized testing. At a small scale, this sort of thing can work, but it only really works when you have very experienced teams working on bespoke systems. And it also costs a lot in time and effort. So lesson number 1 here. Is that it really helps to be immersed in the OpenStack community. Maybe that's an obvious thing to say here at an Open Infra Summit, but the key is picking up on issues before they hit you. We currently have around 60 systems, we can catch problems on staging systems and things before they reach the rest of the clouds. But when you're working on one system, maybe you have a staging system, I don't know. But it can be very difficult to catch things, even if they're known. So paying attention to all of the mailing lists and things like that can really help. So a bit of history. This was the StackHPC approach for many years. And then in late 2020, CentOS 8 is abruptly discontinued and replaced with CentOS 8 Stream. So CentOS is no longer, CentOS Stream is no longer quite as stable as it was. It no longer has minor version releases, and that is key for us. So old school CentOS was downstream of Red Hat Linux, and it had rock solid stability. The new CentOS Stream was moved upstream of RHEL, shifting its purpose from a stable production OS to more of a testing and development platform. At the time, the vast majority of our systems were deployed using CentOS 8 because it was our default at the time. So if our customer said, we don't care, it was CentOS 8. So lesson number 2, if you can't pin it, expect it to break. Have some sort of exit strategy. So this was a major problem for us. Suddenly, any regression could hit us at any time. And this isn't just a theory. We found issues in CentOS Stream that would regularly hit us. So I've got a couple of examples here. The first one, unprivileged users were unable to ping. That's an obvious one. Monitoring services started failing because you couldn't ping the right endpoints. Another one, a memory leak in libvirt. Yeah, that's not going to cause any problems in OpenStack Cloud. But possibly the worst thing for us was it was no longer possible to wait for a minor release. And in CentOS Stream, yeah, there's no minor releases. You just have to upgrade and hope that you get the same things as last time. When you're managing many clouds, we no longer have that stability of we try it on a test system and we know what it's going to do in the future. So yeah, everything is updating day by day. Containers can help this, and you may think that's the solution to everything. We build all of our containers centrally, and then we deploy them everywhere. But that doesn't perfectly help us. One reason for that is the host OS obviously still needs updating, and you can have exactly the same issues there. For example, PCI pass-through. We've had many instances, well, not many instances, but we've seen instances of host OS packages affecting that, and suddenly your GPUs are broken, and no one likes that. So that's one reason. The other reason is that these container images sometimes are customized on site still. So anything that we can bring back to upstream, we will. But upstream has a policy of generally not allowing the backporting of features. So we do customize the containers sometimes for some clients. And if you're doing that, you're rebuilding containers at different times, and we have exactly the same issue because we're using upstream packages. So we have the same problems. A couple of sources for those. So what do we do? One option is we move everyone to Ubuntu. This was our secondary option at the time. We could do that, but we would probably lose a few customers. It's really nice to be able to offer multiple operating systems just as a value add, you know. There were other options though. We could try something like Rocky Linux or Alma Linux, which now are known to be pretty rock solid and work very well. But at the time, we didn't know if we would pick the right one. We didn't know if they would be more unstable than CentOS Stream. We didn't know what was going to happen with them. And we needed a solution that would work today. And our final option is just, do we stick with CentOS Stream? It seems unstable. Maybe we can work around that if only we had those minor versions. Enter our StackHPC escape plan, which is what we call ARC. So ARC is a repository for nearly all of the artifacts you need to build a cloud. It was originally designed to snapshot CentOS Stream 8 package repositories and then build Kolla container images from those package repositories. This would let us validate a snapshot and update to our own kind of minor stable versions, effectively making our own minor releases. ARC is based on Pulp, which is an open source software repository tool with a wide range of support for different artifact types. So generic files, RPMs, debs, so on and so forth. More sources that I forgot to add. And lesson number 3, never waste a good crisis. So if something unexpected happens, don't panic. It can be used as an opportunity to take things in a new, better direction. And over the next 4 years, the scope of ARC gradually grew. So we started off just with CentOS Stream, but once Rocky Linux became stable, we chose it as our migration path away from CentOS. We started out with Rocky 8, then Rocky 9, and soon we'll be adding Rocky 10. And of course, we mentioned earlier that we also support Ubuntu systems. So Ubuntu Focal to begin with, then Jammy, and we now have Noble. There's a few other things as well that don't really fit into this talk, but we do things like NVIDIA drivers, which are very specific to certain kernels. So we can do the same sort of thing. We can build those drivers, and we can store them in ARC and know that we're going to get the same version every time, and it's going to work. So what does it actually all look like? This is the big, scary diagram. We start with upstream. So this is where you pull your packages from when you do sudo apt updates, sudo DNF updates, whatever. We synchronize these into ARC every night. If you're wondering, this takes somewhere between 12 and 18 hours, depending on how many changes there are. And the Ubuntu ones are by far the worst. They're 3 hours on their own per release. Anyway, so we then combine those with certain pinned dependencies from upstream, and we build our container images. We can then push those container images back into ARC, into our development namespace. But of course, we haven't done any testing at this point. Here, we then have a tiny little box that says tests, when in reality, that is probably the biggest part of this, and Seunghun will be explaining how we test things later on. So we test things, we make sure they're all stable, and we move them to our production release. At this point, they become available to all of our customers. They can then pull these packages, they can pull these container images to their cloud, where they essentially have a miniature version of ARC themselves, which just it acts as a mirror and lets them pull everything into their hosts. The other thing that it lets them do is it lets them build their own container images. So we solved that problem from before, that we have those, we can't kind of build container images repeatedly and know that they're going to work. So we've put all of this effort into making things consistent everywhere. But how does that actually help us? Because consistent doesn't necessarily mean consistently good. In fact, consistently bad is always an option and can be much worse than randomness. So how do we make sure that the changes we make actually help us? Lesson number 4, test everything you can. And every test you can, automate it wherever possible. And speaking of, I'm going to hand over to Seunghun to talk about how we do that.
Thank you, Alex. So yeah, tests. Let's talk about the most important part of our release train. We test our contents of our release train very frequently with our CI. Out of all cases, tests are usually done when we develop new features, bug fixes, or when we're updating dependencies. It is also very important to test the new release of OpenStack, because upgrade blindly is like walking through a landmine, I'd say. So yeah, it's full of hazards. Yeah, okay, so it is also very, we can ensure with this way, we can ensure that the packages, images, and upgrades are all safe and tested, and it's good to deliver to customers. We also run periodic test runs with randomized scenarios of OpenStack clouds. This helps us spotting the problems that we couldn't see before, or if we weren't using this CI otherwise. So, what kind of CI and CI test and scenario we use? For scenarios, we make scenarios with the combination of following factors. Host OS. So we actively support Rocky Linux 9, Ubuntu Jammy, and Ubuntu Noble, and soon Rocky Linux 10 once OpenStack starts to support it. Neutral network backend. So normally we deploy OVN to new systems, but we still have systems that uses OVS, so we need to consider both cases. The number of nodes, so it can be a single node test or it can be multi-node test. This is mainly to reduce the resource usage because it's not ideal to run every single test on a multi-node environment, which will need to use 10 nodes. For example, multi-node test typically takes about 10 hours, whereas single node tests will be able to be done up to in 2 hours. And lastly, but I think it's most important, whether or not we include upgrades. It can be OpenStack upgrade or HostOS upgrade. This helps us preventing having breaking changes whenever we are developing something new, so we can know that upgrade path is going to be safe. For the test itself, we run Tempest test for general OpenStack functionalities and StackHPC cloud test to ensure every part of cloud is healthy. So we use monitoring services like Prometheus to check if there's any unexpected alerts firing. We use Docker to check individual containers' health. And we also check the host configuration, such as SLinux, if it's correctly enabled. So this list is quite big, and it's a lot of demand. So we quickly found the limitations from GitHub's hosted CI runners. So we decided to go with self-hosted action runners because we have our own OpenStack, and why not using the resources? To do that, we integrated GitHub's ARC, the action runner controller, not to be confused with our ARC. To do that, so ARC, the action runner controller, is Kubernetes controller for self-hosted action runners. It needs Kubernetes cluster to be used. So where does the Kubernetes comes from? It comes from the OpenStack cloud, either managed and the resource managed by either Magnum and Azimuth. So here's the high-level view of how our CI works. We deployed ARC on the Kubernetes cluster that is managed by either Magnum or Azimuth. For simplicity's sake, we put only one single control plane node here, but in reality, it's a good idea to have more than one. In our case, it's 3 usually. This is for redundancy. So once ARC is set up, then developers can now submit changes to repository and trigger CI, the repository that are configured on ARC, of course. The listener is gonna constantly try to listen job available signal from the repository, and once it have it, the ARC manager will be reported by the listener, and then it will try to start the job. ARC manager is responsible for managing, scaling, and scheduling the runners. So the runners will be spawned on worker nodes, and they will split the resources of worker nodes. Thanks to So as we're using Kubernetes, the automatic scaling helps. So the worker nodes will be they can be scaled horizontally. So when there's many demands, then we can increase the number of worker nodes. Otherwise, we can decrease it. So runner spawned. When runner is spawned, it starts communicating with the repository. It gets CI workflow details from the repository, and then it will reply it with some worklogs and state of work. We use runners as some control host. So runners, they provision VMs using Terraform and Ansible. Depends on what kind of action it's assigned to. So for single node tests, it will spawn a VM. For multi-node, it will spawn multiple VMs. Or it can even spawn VM for image building if the action we're doing is image building. The advantages of this approach are flexibility. Yeah, it's flexible thanks to the auto-scaling with the Kubernetes. The system doesn't need to keep the worker nodes even if there's no action scheduled. It is cost-effective for tests that requires high resources and or time-consuming. Time. So, well, obviously because the resources are ours. Since we use virtual machines and virtual machines are in our control and gets destroyed once the job is done, it is safer to use sensitive data in this manner. Finally, we have full control, so full customization is possible. However, those advantages can become disadvantages in different use cases. Yeah, since we have full control, the more maintenance is needed than when we're using GitHub hosted runners. It's not much, but it's not zero. So, and this setup may not be cost effective if your CI is not used heavily. When the CI is running on the public repository, then we'll need to consider a little bit more on the security side, such as dealing with secrets. And the complexity with all the extra layers from Kubernetes can be not so charming point for some use cases. So finding balance is important. So self-hosted runners are better with time-consuming OpenStack tests, jobs with sensitive data, and frequently used jobs. On the other hand, GitHub runners are better with simple jobs such as linters and Python module tests. Great. So what's next? We're planning to integrate Zoo to better utilize the upstream jobs. We have a plan to add tests with bare metal using Ironic. We like to add complex workload tests for testing applications on top of OpenStack, such as Azimuth or load balancing with Octavia, and long-lived tests for checking system reliability. So, for example, keeping the multi-node OpenStack for about a week, and then running a test again, and see if anything fails. As mentioned a lot, Rock Linux 10 will be added to the test metrics soon, and of course, OpenStack Gazpacho once it's released. And I'll hand back to Alex.
Thank you. So, it's quite late in the day. We've given you a lot of information. So this is the important slide. We've distilled everything down to this. And a lot of what we've spoken about today really only applies at our scale, where we're managing many clouds. We're not expecting everyone to go out and replicate the entire process, because it's just not feasible for most people. So here are some golden rules for when you are managing one cloud, two clouds, that sort of scale. So, rule number one, pay attention to the upstream community. I've mentioned this before, and I will mention it again. The upstream community is your greatest asset. Again, it's obvious this is an open info conference. You probably already know this, but People love to talk about the interesting issues that they've hit, which can help you avoid the same mistakes. You can help people out by mentioning the issues that you've come across. And even raising bug reports and things makes it more likely for your issue to get resolved. So, a very important one. Rule number 2, the best way to break your system during an upgrade is to break it before the upgrade. Your cloud must be healthy before you start, so don't just jump in expecting the new version to fix everything. Resolve the issues before you start. Test and benchmark things before making changes. That is very important, and it's one that I need to remember because I've failed that one before. Rule number 3, time it right. Do not upgrade production on day 1 of a new release. There are bound to be issues. On the other hand, don't wait too long. Dependencies do get stale quickly, and OpenStack support doesn't last forever. So let others chart the course and follow them before the trail is lost. We've generally found that the best time to do this is between 4 and 8 months after a release. That's often the peak of stability if you're quite concerned about that. And rule number 4, make your upgrade as small as possible. In the past, we used to include all sorts of other things when we would do our upgrades. We would add new services, and we take it as an opportunity to just refresh everything. The issue with this approach is that when something goes wrong, there are 100 different things that could have caused it. Just focus on the upgrade, prepare well in advance, and make the smallest possible change on the day. There's more. Rule number 5, start early. Proper preparation takes time. Accept it and account for it. So this can vary quite a lot across releases. Major operating system upgrades are often the most time-consuming part. Usually that involves draining a small subset of your hypervisors, doing the upgrades, shifting things back, and so on. And on larger systems, this can easily take months or years in some cases. And finally, rule number 6, have a plan and write it down. It is very easy to lose track of where you are, so write out what you're going to do and when you're going to do it. Tick things off as you go. The plan should always start and end with a comprehensive test suite, because the worst case is you upgrade your system on Monday and only notice a problem on Friday afternoon. And I think that is it. Thank you very much for coming. If you have... So if you want to take a picture of this now, please do. If you have any questions, I have no idea how much time we have.
We have
about 1 minute. Anything? Yeah, go ahead.
Upgrade or something, or Kolla Ansible upgrade, there will be some tasks started like updating a database scheme or some scripts started